Good day. Today we will be looking at Module 2, Analytical Geometry, Unit AG2, and specifically equation of a circle with the center 0, 0. Now a circle can be defined as a set of points at a fixed distance from a fixed point. And in this lesson, we will specifically look at the circles with the center at the origin, 0, 0. Now, it is a fact that the radius of a circle is a constant value. So the radius at any point will remain a constant value. Now, the length of the radius of a circle with center the origin is measured from 0, 0 to any point x, y on the circumference of the circle, and it is calculated with the distance formula. In other words, when we use the distance formula, we can say that r squared is equal to x minus 0 squared plus y minus 0 squared. If I then simplify, x minus 0 is x and squared, and y minus 0 is y and also squared. So the standard form of the equation of a circle with the origin as the center is then given by r squared equal to x squared plus y squared. It is important to know the standard equation of a circle with the origin as center. So you have to study this formula. X squared plus y squared is equal to r squared. We can now look at example 1. Find the equation of a circle with the origin as center passing through 2 and 5. So we know that the standard form of a circle with the origin as center can be written as r squared equal to x squared plus y squared. Since we are given a coordinate where x is 2 and y is 5, I can now substitute the x value of 2 as well as the y value of 5 into my equation. If I then simplify, 2 squared is 4 and 5 squared, 5 times 5 is 25. 4 plus the 25 gives me 29. So r squared is equal to 29. Therefore, my equation of my circle with the origin as center can then be written as x squared plus y squared equal to r squared, in this case equal to 29. In example 2, we are now asked to determine the radius of the circle when the equation is given to us, x squared plus y squared equal to 169. Now we know that r squared is equal to 169. If I then square root both sides to get rid of the square and to get r alone, I will have the square root of 169, which is 13, because 13 times 13 gives me the 169. Remember, we only use the positive solution because a length is always positive. So the negative 13 in this case will not be applicable. The questioning can also be manipulated in the following way, as in example 3, where a point is given to us where the x value is a and the y value is the square root of 5. We are told that this coordinate lies on the circle x squared plus y squared equal to 21, and we have to determine the values of a. In other words, we will substitute the x with a and the y will be substituted with the y value of the coordinate square root 5. And then we will simplify the equation in order to solve a. So I substitute my x with the x value of the coordinate, in this case the a, and I substitute the y with the y value of my coordinate, in this case the square root 5. I can now simplify my equation in order to solve a. The square root and the square cancels one another out, and I'm left with the 5. If I then take the 5 to the right hand side, it becomes minus 5, and 21 minus 5 is 16. If I now want to solve a, I have to take a square root on both sides in order to get rid of the square, and the square root of 16 is positive or negative 4. Remember, the square root of an even root always has a positive or negative solution. So in this case, if I have a equal to a positive 4, 4 times 4 is 16, or a could be equal to minus 4 because a minus times a minus is also a plus. 4 times 4, 16. Let's now look at the last example of this lesson, example 4. We are given a coordinate P of minus 5 and 12, which lies on a circle with center the origin 0, 0. We are asked to determine the equation of the circle, so we will use the standard form of a circle with center the origin, the x squared plus y squared equal to r squared. Then question B, determine the coordinates of Q if PQ is a diameter. Now we need to draw up a rough sketch where we have the given coordinate P, where x is minus 5 and y is 12. And then if we have a diameter, it has to be a line that goes through the origin, because the origin is the center of the circle, and a diameter has to go through the center. So in other words, I can estimate that Q will lie more or less here on the circumference of the circle. Then in question C, we have to show that R, 0 and minus 13 lies on the circle. Now to do that, we can also just draw a rough sketch of the point R, and then we will work with a left hand side and right hand side separately in order to prove that this coordinate lies on the circumference of the circle. Then for D, show that PRQ is equal to 90 degrees. In other words, if we can prove that this gradient times that gradient is equal to minus 1, then we have perpendicular lines. And that will then prove that that angle is 90 degrees. So let's first look at the solution of A, where we have to determine the equation of the circle. We know it's a circle with the origin as the center, and therefore we use the standard form x squared plus y squared equal to r squared. We were also given a coordinate where we will substitute the x value with minus 5, and the y value will then be substituted with 12. If I then simplify, I can work out the value of r squared. Minus 5 squared means minus 5 times minus 5 is a positive 25, and 12 squared, 12 times 12 is 144. If we add it together, 25 plus 144, we get 169, and therefore r squared is equal to 169. I can then conclude that the equation of my circle with a center at the origin is equal to x squared plus y squared equal to r squared, which we've worked out equal to 169. In question B, we have to work out the coordinate Q. We know that PQ is the diameter of the circle. In other words, a rotation of 180 degrees took place. Now this is where transformation geometry comes in, and the background knowledge is very important, because if we have a rotation of 180 degrees, then we have the same x and y values but with different signs. In other words, Q will become a positive 5 as an x value, and the y value will become a minus value. So we can conclude that after a rotation of 180 degrees, the x value will now become a positive 5 and the y value will become a negative 12. In question C, we have to prove that the coordinate 0 and minus 13 lies on the circumference of the circle. Therefore, we can now take the equation of the circle, which we've calculated in A, and work with the left-hand side, x squared plus y squared. Substitute the coordinate values. X is substituted with 0, y is substituted with minus 13. And if I then simplify, 0 squared stays 0, minus 13 squared, a minus times a minus becomes a positive. 13 times 13 is 169. It is indeed equal to the right-hand side of 169. So I can conclude that the left-hand side is equal to the right-hand side, and therefore this coordinate 0 and minus 13 lies on the circle. Now for question D, to prove that the angle PRQ is equal to 90 degrees, we have to show that the gradient of PR times the gradient of RQ is equal to minus 1. So if we have perpendicular lines, then we can conclude that the angle PRQ is equal to 90 degrees. So if we work out the gradient of PR, we will take the y values, the y of P minus the y of R, in other words the 12, minus the minus 13 becomes plus 13, and then the difference in the x values, the x of P minus the x of R, in other words the minus 5 minus the 0. We will then simplify. 12 plus 13 is 25, minus 5 minus 0 is minus 5. A positive divided by a negative is a negative, and 25 divided by 5 gives me the gradient of minus 5 for PR. Then we can also work out the gradient of RQ by taking the differences in the y values over the differences in the x values. In other words, if I take the y of R minus the y of Q, it will be minus 13 minus the minus 12, which becomes a plus 12. And then the difference in the x values, the x of R minus the x of Q, in other words the 0, minus the 5. I can then simplify. Minus 13 plus 12 is minus 1, and 0 minus 5 is minus 5. A negative divided by negative becomes a positive, and then I'm left with the fraction 1 over 5. I must now check whether the two gradients multiplied by one another will give me minus 1. In other words, are they perpendicular? So I will take my gradient of PR, the minus 5, and multiply it by the gradient of RQ, the 1 over 5. And when I multiply them with one another, it gives me the minus 1. Therefore, I can now conclude that the line PR is perpendicular to RQ, and therefore my conclusion then that angle PRQ is indeed equal to 90 degrees. Now that brings us to the end of this lesson, and you can now start with the activity. Let's have a look at what is expected of you in this activity. For question 1, determine the equation of the circle with center the origin and with radius given, r equal to 6, r equal to 3 over 2, and r equal to the square root of 13. In other words, we can use the standard form of an equation where the center is the origin and then set it equal to r squared. So we will just square the r value. Then question 2, determine the equation of the circle with center 0, 0 and the following point on the circumference. Again, we will use the standard form of the equation of a circle with the center, the origin, the x squared plus y squared equal to r squared. And now we will substitute the given point into the x and the y value in order to solve the r value. Then question 3, determine the radius of the following circles. We are now given the standard form of the equation of a circle with a center, the origin. So we know that the value on the right hand side of the equation is in the place of the r squared. So we will simply just square root the r squared in order to get the value of the radius. In 3b, we must first write the equation in the standard form. So the minus 49 will be taken to the right hand side and become a plus 49. So r squared will then be equal to the positive 49, and then we can solve the radius. In question 4, we are given the point P with an x value a and a y value square root 7. It lies on the circle x squared plus y squared equal to 8. Determine the values of a. So we will simply substitute the x value and the y value and then solve a. You must now first stop the video, complete the activity on your own before you listen to the memorandum discussion. In question 1, we were told that we have an equation of a circle where the origin is the center, and we were given the different r values. So we had to substitute the r value into the equation and square it because the equation is equal to r squared, and therefore the 6 squared will become 36. So my equation will be x squared plus y squared equal to 36. The same with question 1b. I will take my r value, the 3 over 2, and square it. 3 squared is 9, 2 squared is 4, so my equation is x squared plus y squared equal to 9 over 4. Then for question C, we were given the r value of square root 13, and it must also be squared. The square root and the square cancels one another out, so I'm left with the 13, and therefore my equation of a circle with the center, the origin, is x squared plus y squared equal to 13. In question 2, we were given a certain point on the circumference of a circle where the center is the origin, and therefore I still use my standard form of the circle equation, x squared plus y squared equal to r squared, but now I substitute the coordinate given to me into the x and the y values. So we were given the point where x is 3 and y is minus 4. So when I simplify my substitution, 3 squared is 9 and minus 4 squared becomes plus 16. 9 plus 16 is 25. So r squared is equal to 25. So now in the place of the r squared, I will write my value 25. So the equation of this circle with a center, the origin, is x squared plus y squared equal to r squared, which we've worked out is 25. The same then for question 2b. We were given a coordinate or a point on the circumference of the circle where x is minus 1 and y is square root 7. So once again, I use my standard form of an equation of a circle where the origin is the center. So we take the x squared plus y squared equal to r squared. We then substitute the given coordinate, the x value substituted with minus 1, the y value substituted with the square root 7. If I then simplify, a negative squared becomes positive, and 1 squared, 1 times 1 remains 1. Then the square root and the square cancels one another out, and the 7 remains. So therefore I will have 1 plus 7, which is 8, so r squared is equal to 8. Now I have to substitute my r squared into my standard equation, and therefore the equation of this circle will be x squared plus y squared equal to r squared, in this case equal to 8. In question 3, we were given the equation of the circle and we have to work out the radius. So it is as simple as taking the value of the r squared, which was given as 81, and then get r alone. Therefore, I will draw a square root on both sides so that the square root and the square cancels out and get r alone. And the square root of 81 is plus or minus 9. Remember that the negative 9 in this case is not applicable because a distance is always measured as a positive unit, and therefore only the positive 9 is applicable in this solution, so the radius has a length of 9 units. Then in question 3b, we said that we just have to rewrite the equation and put it in standard form. So the minus 49 was taken to the right-hand side and became a positive 49. So the 49 is in the place of the r squared. And since we want to work out r, we can then say that r squared is equal to the 49. To get rid of the square, we have to draw a square root on both sides. The square root and the square cancels one another out, and I'm left with the r on the left-hand side. And then the square root of 49 is plus or minus 7. Once again, I only use my positive value because the distance or the radius is always a positive value. Then question 4, we were given the equation of the circle being x squared plus y squared equal to 8. And we were also given the coordinate where x is a and y is square root 7. So we substitute x then with the a value and y is substituted with the square root 7. If I then simplify, my square root and my square will cancel out and I'm left with the 7. If I take my 7 to the right hand side, it becomes minus 7, and 8 minus 7 is 1. So then to get rid of the square, I have to draw a square root on both sides again, and the square root and square cancels one another out, so I'm left with a on the left hand side, and the square root of 1 is plus or minus 1. Remember, an even root always has a positive or negative solution, because if I take my minus 1 and I square it, a minus times a minus becomes positive, and 1 times 1 is then a positive 1. And the same goes for the positive solution. Plus 1 times plus 1 is also 1. So the values of a will then be plus or minus 1. So that brings us to the end of this lesson, and you may now continue with the next one.